Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Special array 1, Leetcode 3151. In this problem we are given an array of integers, nums, and we should return true if nums is a special array, otherwise we should return false. An array is considered special if every pair of its adjacent elements contain two numbers with different parity. That is, if one number is even, the other number should be odd, or if one number is odd, the other number should be even. Then in example 1, given array has only one element, so it doesn't violate any parity check, and hence we will return true. But in example 2, we have three elements, and first element is even, then the next element is odd, and then again next element is even. So no two elements have same parity, hence it's a special array, so we will return true. Finally, in example 3, we can see that first number is even, next number is odd, then next number is odd again, and the last number is even. So here we can see that there are two adjacent elements, 3 and 1, which are both odd. So this is not a special array. Now in terms of solution, we have to check the parity of each number. And how can we do that? One way is that we can use modulo operator. The modulo operator returns the remainder after division of one number by another. So if we divide a number by 2, we can either get remainder as 0 or 1. So if remainder is 0, that means number is divisible by 2 and hence it is even. But if the remainder is 1, that means number is not divisible by 2 and hence it is odd. For example, 3 modulo 2 is equal to 1, implying 3 is an odd number. But 4 modulo 2 is an even number because division by 2 here leaves no remainder. Another way can be that we look at the binary representations of number, especially at the least significant bit. So for example, the binary representation of 3 is 1, 1. And if the least significant bit is 1, then the number is odd. Otherwise, if it is 0, like in case of 4, then it is an even number. And how can we check if least significant bit of the number is set or not? And the answer here is we can use an AND operator. The AND operator returns 1 only when all the corresponding bits are set. To check the least significant bit or LSB, we can use binary AND operator with the number 1 as 1 has only the least significant bit set. If the result of the binary AND between number and 1 is 1, then the number is odd because the LSB in it is set. But if the result is 0, the number is even because the LSB in the number is unset. For example, let's take the binary representation of 3 again. It is 0, 1, 1 and binary representation of 1 is 0, 0, 1. So if we do AND operator between them, then we will get 1 and 1 as 1, 1 and 0 as 0 and 0 and 0 as 0. So only the LSB is set. But bitwise and between 4 and 1 will result in 0 because the 0th bit in 4 is not set. So because of this, 4 is an even number. So now we can iterate through the array and check each pair of adjacent element and ensure they have a different parity. If any pair has the same parity, then we will return false. So for example, here 2 modulo 2 will give us 0. So this means this is an even number. Then 1 modulo 2 will give us 1. So that means 1 is odd. And now we compare the parity of two adjacent elements. So 0 is different from 1. So we will continue. So then we do 4 modulo 2 and that is again 0, which is different from previous remainder, that is 1. So because none of the remainders was same, this is really a special array. Now let's code it up. First let's iterate through the nums array from index 1 to the end of the array so that we can compare the parity of current number with that of previous number. Now for each element, we will check if its parity is same as that of previous element. We can check that by comparing the remainder of two numbers when divided by 2 using the modulo operator. If it is, then we will return false. Otherwise, if we didn't find any violations of parity check, we should return true. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is length of the nums array because we are going through each element only once. And in terms of space complexity, it will be O of 1 because we are using some variables here and there. Coming back to our solution, here we need the parity in an alternating way. If both the parities are same, that is, both the adjacent numbers are either odd or even, the array is not special. If you observe carefully, this resembles the behavior of the XOR operator, where the result is 1 if the bits are different, but 0 if they are same. For example, 0 XOR 1 and 1 XOR 0 is equal to 1, but 1 XOR 1 and 0 XOR 0 is equal to 0. Therefore, by XORing the parity of adjacent element, If the XOR result is 0, that implies same parity of the adjacent element and hence array is not special. Now let's implement this in code. So instead of putting the equality sign here, we can put XOR operator. And now if at any point the XOR between the parity of the current number and the previous number is 0, that means these two numbers have same parity. So we will return false. Rest of the code can stay same. Let's submit this code. And we can completely switch to bitwise operators. We can perform bitwise and between the number and 1, and rest of the code will stay same. Let's submit this code as well. And needless to say, but still reiterating, the time and space complexity of this approach also stays the same. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.